Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. The topic of this lecture is loci in complex numbers. An important advice: we must always be sincere to others. You can find the link of the math website in the description where you can find the soft copy of this lecture. Loci. A locus is a path traced out by a point as it moves following a particular rule. The rule is expressed as an inequality or an equation. The standard equation of circle in complex numbers. This is the standard equation of circle in complex number, where this z means the variable point, this v means the center of the circle, this r means the radius of the circle, and this negative sign is the part of the equation, and this is the modulus. We can describe the locus of z into this equation as the locus of z is a circle with center at v and radius r. Well, this is not the right equation of this circle, because for the right equation of this circle, the center must be inside the bracket and there must be a negative sign outside the bracket. So by taking negative sign common from these two terms, we can get the right equation of the circle. Hence, this is the right equation of the circle. In this equation, the center of the circle is at 2 plus 2i and radius is 1 unit on Argand diagram. Well, if this is the equation of this circle and if this is the center, then this is the Argand diagram of this circle. Since we have equal signs, so z is anywhere on the circumference. And this is the center. Since both the parts of the complex number are positive, so center is in first quadrant. This is the modulus of the center, this is the argument of the center, and this is the radius of the circle. Here we have an inequality and there is a lesser equal sign. So we have to shade inside the circle because z is either on the circumference or inside the circle. Example number 1. Shade the region which satisfy this inequality. Number 1, we have to simplify this inequality. The center must be inside the bracket. So we need to take minus sign common from these two terms. Here is the right inequality of the circle. The center of the circle is at 2 plus 2i and radius is 1 unit on Argand diagram. This is the modulus of the center. And the argument of the center is either 45 or pi by 4 because center lies on y is equal to x. Here is the Argand diagram of this inequality. See, this is the center 2 plus 2i, this is the radius, this is the modulus of the center which is 2 root 2, and this is the argument of the center, and shade inside the circle because of lesser equal sign. The next topic, in circles. The topic is greatest and least values of argument z. Well, to find the least and greatest values of argument z, you have to draw two tangents from origin to the circle. Because when you will draw this tangent from origin to this circle, you will get the smallest argument. This is the smallest argument of z, because when z is here, this angle is the smallest. And when z is here, then this angle is greatest. Let's understand how to find these two angles. See, first draw two tangents to the circle from origin. And when z is here, this angle is the smallest, and when z is here, this angle is largest or greatest. So in order to find this angle, we must have this angle x, because this total angle is 45 or pi by 4. So once we have this angle, we can easily find this angle and this angle as well, because both triangles are congruent. This is the equation of the circle, and we have to find greatest and least values of argument z. This is the Argand diagram of this equation. See, center is at 2 plus 2i, argument of center is 45, and modulus of center is 2 root 2. Now for the least argument, z must be here. See, this is argument z least. To find this angle, we must have this angle. So by using sin x into this triangle, we can easily get this angle. So sin x is 1 upon 2 root 2. Therefore x is 20.7. You can check this working here. This total angle is 45. We have found this angle. Now we can easily get this argument. This argument should be 45 minus 20.7. This solution is here. This is the argument z least. 45 minus 20.7. For argument z greatest, you have to draw tangent from origin to this circle here, because when z is here, this angle is greatest. This is here. This angle is 20.7. Therefore, this total angle should be 45 plus 20.7, which is 65.7. So remember this concept. Whenever you have to find greatest and least values of argument z, then always draw two tangents from origin to the circle. Hence, argument z least is this and argument z greatest is this. Always draw Argand diagram for this. The next topic, greatest and least values of modulus z. So when z is here, then this distance is greatest. Modulus z means distance of z from origin. And when z is here, then this distance is shortest. So we can easily find these two distances, this one and this one. For modulus z greatest, we need to add radius into modulus of the center. Modulus v plus radius. This is radius. So modulus v plus radius will give you greatest value of modulus z, which is 2 root 2 plus 1 in this case. And for modulus z least, this distance, we need to subtract radius from modulus of the center, modulus v minus radius, which is 2 root 2 minus 1 in this case.